All right, here are your 4.1 notes applying triangle sum properties. We also need to be able to classify triangles by angles and by sides. So first, classifying triangles by angles. An acute triangle will have 3 acute angles. Remember, acute angles are angles less than 90 degrees. There are also right triangles, which have 1 right angle, right angles being 90 degrees. There are obtuse triangles, which have 1 obtuse angle. Remember, obtuse angles are more than 90 degrees. Or they could be equiangular triangles, which have 3 congruent angles. So the 4 types of triangles classified by angles: acute, right, obtuse, and equiangular. Classifying triangles by sides. First we have scalene, which have no congruent sides. No sides are the same length. Isosceles have 2 congruent sides. Or equilateral, which have 3 congruent sides, all sides the same. So scalene, no congruent sides. Isosceles, 2 congruent sides. And equilateral, 3 congruent sides. Then there are 2 theorems that we need to learn. The triangle sum theorem, which states the sum of the interior angles of a triangle is 180 degrees. So all angles inside of a triangle add up to 180 degrees. And the second one, the exterior angle theorem, which states the exterior angle equals the sum of the 2 non-adjacent interior angles. And we'll see what that looks like in some of the examples. So first, let's practice classifying some triangles by sides and by angles. The sides are classified in red, angles classified in blue. So this first one, letter A. We look at the sides first. We have 19, 8, and 23. None of those are the same, so it is a scalene triangle. Then looking at the angles, 19, 51, and 110. 110 is more than 90 degrees, so it is an obtuse triangle. It has 1 obtuse angle. It's an obtuse triangle. Then looking over here at B, look first at the sides, 4, 4, and 4 root 2. 2 of those sides are the same, 4 and 4. So it's an isosceles triangle. Then looking at the angles, 45 degrees, and 90 degrees. We have 1 angle that is 90 degrees, so it is a right triangle. Then looking at C, look first at the sides, 17, 17, and 17. All sides are the same, 3 congruent sides. It is equilateral. Then looking at the angles, 60 degrees, 60 degrees, 60 degrees. All 3 angles the same. It is equiangular. Then looking here at D, first look at the sides, 5, 2.9, 5.8. They're all different, so it's scalene. And then look at the angles, 30, 60, and 90. We know it's 90 degrees because it shows it's a right angle. So it is a right triangle. E, look first at the sides, 10, 10, and 18. So we have 2 sides the same, 10 and 10. It is an isosceles triangle. Then at the angles, 30, 30, and 120. 120 is more than 90, so that's an obtuse angle, so it's an obtuse triangle. Then number 2 here, we need to classify the triangle PQO by its sides, then determine if the triangle is a right triangle. So here is P, Q, and O on the coordinate plane. We know the points, -1, 2, 0, 0, and 6, 3, but we don't know the lengths of these sides. So we need to use the distance formula. Knowing the 2 points, we can use the distance formula to find the lengths of the sides. Then we can classify the triangle by its sides, and then we'll look at a way to figure out if it's a right triangle or not. So we're going to use the distance formula, which is d equals the square root, and really the square root line should go all the way across the top. X2 minus x1 squared plus y2 minus y1 squared. So if we look first at PO, the line PO, plug in our points for x2 and x1, that's -1 and 0. The x's from P, or the x from P and the x from O. Square that gives us 1 over here. And then plug in our y's, 2 and 0. So 2 minus 0, square that, is 4. So the length of PO is the square root of 5. So this length is the square root of 5. Then we need to look at OQ, plug in our points. That's our green point and our blue point. So plugging in 6 and 0 for the x's, 3 and 0 for the y's. And that'll equal the square root of 36 plus 9. 36 plus 9 is 45. So OQ equals the square root of 45. So we know 2 of the sides, square root of 5 for PO, and the square root of 45 for OQ. Then our final side is QP. Plug in our x's, -1 and 6. So -1 minus 6 gives us -7. Square -7, that gives you 49. Then plug in our y's, 2 minus 3. 2 minus 3 is -1. Square -1, that gives you 1, +1. So we have 49 plus 1. So the length of QP is the square root of 50. So we know all 3 sides, square root of 5 for PO, square root of 45 for OQ, and the square root of 50 for QP. No sides are the same length, so it's a scalene triangle. Now we need to determine if it's a right triangle or not. And anytime we want to prove a right triangle or find out a side length of a right triangle, we use the Pythagorean theorem, which is a squared plus b squared equals c squared. So in this case, we know a, b, and c, but we want to know if it's a right triangle or not. So if it comes out true, it is a right triangle. So we plug in, we'll plug in square root of 5 for a and square it, which gives us 5. Plug in the square root of 45 for b and square it, which gives us 45. And we'll plug in the square root of 50 for c and square it. Now the reason I chose square root of 5 for a, square root of 45 for b, and square root of 50 for c, the a and b is not as important. I could have switched my square root of 5 and square root of 45 if I wanted. But square root of 50 had to be c because it's the larger number. The larger number will always be placed for c. So we have 5 plus 45 equals 50, which is 50 equals 50. Obviously, that is true. So this is a right triangle. Yes, it is a right triangle. Had this come out 49 equals 50, then no, it would not have been a right triangle. All right, we've got a few more examples to look at. For this, we need to find the angle measures. So we're finding the measure of angle BCD and the measure of angle ABC. That's what it's asking for. ABC is this 2x up here, and BCD is the 5x minus 2. So we are going to use the exterior angle theorem. We need to find x first. So we see an x here with the 2x and an x here with the 5x minus 2. We need to find the value of x. So the exterior angle theorem tells us that 5x minus 2, which is our exterior angle, is going to be equal to the sum of the two non-adjacent interior angles. So we're going to add 2x plus 76 and set that equal to 5x minus 2. So 2x and 76 are our non-adjacent interior angles, meaning they are not next to 5x minus 2. They're the angles inside the triangle furthest away from our 5x minus 2. So we set it up over here. 2x plus 76 equals 5x minus 2. Subtract 2x from both sides. That'll give us 3x. Add the 2 over to 76. That gives us 78. Then divide by 3, and x equals 26. Then we can plug x back in. So first for triangle ABC, that's our 2x. We have 2 times 26. That gives us 52 degrees. So the measure of angle ABC is 52 degrees. Then our exterior angle, BCD, we plug in 26 for x, so we have 5 times 26 minus 2, and that'll give us 128. So angle BCD equals 128 degrees. In our next example, we're going to be finding the measure of angle BAC. That's this bottom angle down here, the 3x plus 11. And we also need to find the measure of angle BCA. That's the one over here on the right, the 4x minus 5. So first we need to find x. And we're going to do this using the triangle sum theorem, which I said all three interior angles add up to 180 degrees. So we have our 3x plus 11, 90 degrees, because we know this is 90. It shows us as a right angle. It's 90 degrees. And plus 4x minus 5. Set all of that equal to 180. Combine your like terms. So 3x plus 4x gives me 7x. 11 plus 90 is 101. Minus 5 is 96. And equals 180. Then we can subtract 96 on both sides. That gives us 84. So we have 7x equals 84. And then divide by 7, and that gives us x equals 12. So now we can plug 12 back in. So first we're going to solve for angle BAC. That's the bottom angle, 3x plus 11. We'll plug in 12 for x. So 3 times 12 gives us 36. Plus 11 gives us 47. So angle BAC equals 47 degrees. And then the second angle, BCA, the 4x minus 5 angle, we plug in 12 for x. We have 4 times 12, which is 48, minus 5 is 43. So angle BCA equals 43 degrees. All right, and then we have one more example. We're going to be finding x and angle 1. So here's our triangle and exterior angle. We need to find out what x is, and we need to find the measure of angle 1. So angle 1 is the only angle it's asking for a specific measurement of. We need to find x and the measure of angle 1. So we'll find x first. We can use our exterior angle theorem. So we have 5x minus 10 equals the sum of those two interior angles that are non-adjacent to it. So that's 40 and 3x. They're the furthest away from 5x minus 10. So we set it up 40 plus 3x equals 5x minus 10. Subtract 3x to both sides, from both sides, and that will give you 2x. So 5x minus 3x gives us 2x. And then add the 10 to both sides. So 40 plus 10 gives us 50. So we have 50 equals 2x. We want to get x by itself, so divide by 2. So we have 25 equals x. So now that we know 25 is x, we can actually solve for angle 1 a couple different ways. What I used was knowing that angle 1 and angle 5x minus 10 are a linear pair. We have this line across the bottom and this line dividing them. So we know it's a linear pair. Linear pairs add up to 180. So that's the method I used over here. After we solve this way, I'll show you the other way as well. So we have angle 1 plus 5x minus 10 equals 180. So I plugged in 25 for x. So that gives me 5 times 25, which is 125, minus 10. So angle 1 plus 125 minus 10 equals 180. 125 minus 10 is 115. And then we need to subtract the 115 over to the other side. So subtract that from 180, and we're left with 65. So angle 1 equals 65 degrees. The other way you could have done this, and you may have already recognized, we talked about all three interior angles adding up to 180. So I could set it up 40 plus 3x plus angle 1 equals 180. And since I know x is 25, I could plug that in. So 3 times 25 will give me 75. 75 plus 40 is 115. And then if we subtracted it to the other side, we'd be left with 65 equals angle 1. So either way, recognizing this is a linear pair, you could do that, or you could add up all three interior angles and set them equal to 180 as well. All right, that is the notes for 4.1.